Here we have a generic enumeration called computed. The get and set type aliases it uses are supplied with their concrete types by making a concrete computed type, which we'll do down below. This is in contrast to using generic type aliases directly in Swift 3, as we did with process.
This was possible prior to Swift 3, but Swift 3 removes the need to have generic type aliases be wrapped up in types. This is the way we're choosing to express these type aliases in Swift 3 because generic set is already in the Swift namespace as a noun, not the verb that we want. This is the set you're probably familiar with, and we need to be able to disambiguate from that.
Let's use the generic type to create a setter for an instance. In this case, a Boolean called bool. We can do this completely explicitly, like this, where we say a computed bool's set. But what's cool about generic types is that the compiler can infer generic placeholders, as we're doing in the second example. So this is still going to be a computed bool set, but we don't need to say what's in the angle brackets. The compiler knows that. In realistic Swift usage, though, you wouldn't need either of those because this can all be completely inferred by the compiler.
That's amazing.
No explicit typing there.
Now, the compiler doesn't actually care about your type alias. It's for your usage only. If you option click on each of these, you'll see that their markup is different. First, we have a bool that returns void. Then we have a bool in parentheses that returns void. And then we have a bool in parentheses that returns an empty tuple.
None of these are using our actual computed type because that's only a name for our usage. It doesn't actually affect compilation.
We don't know why these are different. It's a mystery to us. So if you know, let us know.
So let's create a struct so that we can see a use case where you would actually need explicit typing. Here we have a struct called boolBuddy. It has a property called setBool, which is of type computed bool's set. That is a closure which takes a bool and returns nothing. This other stuff here is to emulate what you might have in a realistic struct, just so we had some reason to put setBool in here with something else.
Just totally normal other stuff.
So you need an explicit type for setBool in this case. Also notice that we have an underscore. We're currently using set underscore to denote that a function or closure will set the thing that comes afterwards.
So let's check out how we would use this. Here, we have a bool, which is a bool. Right now it is true. And then we're going to create a boolBuddy called booty. And then we'll use it to set our bool to false. And ta-da! It is false.